Welcome, all of you, to the Ontario Science Centre and our Engineering Innovation Forum, part of National Engineering Month. Now, I'm honored to be served as your moderator, although when I was asked, I was kind of picturing myself to be a bit like TV Ontario's Steve Paikin, basically policing a political or federal debate with unruly politicians. But I guess I've only got a few combative engineers to deal with tonight, and I'll let you guess who they were. Engineering the Pan Am Games, fantastic topic, and I've got to say I'm a fan of both community and sport. It makes sense for me. And just to get you hyped up a little bit about the Pan Am and the Para-Pan Am Games this summer, 106 days from now, you'll see 7,000 athletes from 41 countries around the Americas and the Caribbean descend on Toronto and Southern Ontario for what will be the largest multi-sport games ever held on home soil. So bigger than the 1976 Olympics, bigger than Vancouver 2010, bigger than Calgary 1988. So pretty impressive. I'm especially proud because my network, CBC, is the host and official broadcaster of these games, both the Pan Am and Para-Pan Am Games. And just a quick Cole's notes on me, which Paul alluded to. I've covered professional and amateur sport for the last 15 years with CBC, and my passion is with high-performance sport. I've covered 8 Olympic Games, including this past winter in Sochi, and I've seen firsthand what a multi-sport games can do to a community and to a nation. I look at my community, my hometown of Halifax, and what the facilities for the Canada Winter Games have done there. And even the athletes that we cover on CBC every weekend, they all seem to come from Calgary. That legacy of 1988, every Olympics after that basically tried to design the exact same Olympic oval that you see in speed skating. And still, 27 years later, Calgary's ice is the fastest in the world. First up to break the ice with his, I'm told, good sense of humor and expertise, Douglas Birkenshaw, a principal with B+H Architects. And just a little bit about Douglas before we bring him up. He's been with B+H since 1993, a senior design leader, combines his architectural visualization with advanced architectural imaging software, and that comes straight from his bio. I can't come up with that. He's been recognized with several major awards for his work and had primary roles in several of the venues that you'll see this summer, the Markham Aquatic Center, and the one that a lot of people are talking about, the Pan Am and Para-Pan Am Aquatic Center and Fieldhouse at the University of Toronto Scarborough campus. Here he is with his presentation, Games versus Legacy, Creative Solutions to Delivering a Community-Based Games, Douglas Birkenshaw.
Thank you. I'm just going to start my watch because I always go over. I'm not an engineer. I'm an architect, so I feel like I'm in the bull pit or whatever the phrase is. You guys all make me very nervous. I deal in fantasies, and my job is to synthesize people's aspirations, desires, and budgets, and make a nice package and a building that will somehow encompass those. So without further ado, I will try and describe how we did this with some of the Pan Am venues. Our role on this particular project was to be the architects who set up the idea for the buildings, who work with the clients directly, to create a bid package, essentially, that can go forward, and we'll talk about that in a little more detail. And as well, we actually executed 3 of the venues in a standard sort of STIP sum build or a bid build process. So just to talk about some of the challenges there, this was a Infrastructure Ontario guided process. All of the venues were pretty much executed in that fashion. And so that was one of the challenges, just to work within that format with a multiple tenants group in different sort of scenarios, but also just building a modern games that was explicitly meant to leave no legacy of white elephants, but in fact to leave a legacy, as was described by Sigma, to to have a kind of extraordinary facilities left over to improve the health of the community, and also as a kind of legacy for future Olympians and high-performance athletes. So just a quick tour of where sports have gone. Most of our kind of concept of modern games, certainly Olympics and Pan Am sports. Olympics are really only 115-ish years old. Pan Am sports are some 80 years old. And in the early days, everything was amateur. This was a fantastic group of female archers. That you can see the kind of concept of performance was fairly limited. Just showing up was enough. Now, of course, everything has become super high-tech. We have kind of an extraordinary pieces of machinery that bear no resemblance to the original format. And of course, these people have engineered their bodies literally to become these kind of high-performance athletes. Even recent games, this is Atlanta. I mean, look at these people. They're almost cute in their innocence, shaved bodies. Yes, for performance, but look at the bathing suits. I mean, oh my God. Whereas now we have bathing suits that are kind of turning into these extraordinary machines to improve the kind of characteristics to the point where they're so kind of specific that they only last for one event. They're worth like $700 each. So they've been kind of limiting the sport. They started to limit the sport to only the rich. And finally, the governing body said this is unfair. We have to, sports have to be about including people who have limited means. So they banned these particular outfits now because they in the 2008 Olympics, they broke something extraordinary, like 8 records in swimming. And it's all because these outfits, not only they streamline, but they create more buoyancy so you can fly literally across the water in a way that you never used to be able to. And then, of course, the cuteness of let's go and run. But, of course, that's not what we do now. Everything is a kind of pure science. Every single aspect of the process is now part of running. So the 100-meter dash, for instance, the marathon in 1896 was run in 2 hours and 58 minutes. One of its most recent records is 2 hours and 6 minutes with 2 extra kilometers, so that's an improvement of 29%. But basically, in the past 10 years, it hasn't been getting much better, and that includes the 100 meters. Most of the sports, we've had a flattening out of the process. So now what's happening is the focus is on the venue. How do you improve the venue? So we've kind of gone as far as we can. We're kind of making incremental gains in literally engineering the athletes. And now we're looking at engineering the venue. So the track becomes critical, the blocks and how you come out of them, the shoes. Are you running on a wind day? And if wind is a factor, then let's run inside. And so we start to kind of to take these elements that used to be kind of very simple, like field hockey, and start like, okay, the field has to be absolutely perfect. The shoes have to be extraordinary. We have to be able to, So now we have, the athlete becomes like this machine that we study ad nauseum. And even when it comes to the parapan stuff, the technology that's going into these things, like this guy can run faster than the majority of Olympic athletes of the past century. Because the technology is caught up, he can run a 100-meter dash in like, under 10 seconds. This is an extraordinary thing, but again, it's all the technology that's going into it. And of course, the timing itself and the photography becomes a critical element in the thing, because to raise money for sports, of course, you have to make it entertaining. So the venues themselves have to contain all this stuff. They have to contain the science of the sport. They have to contain the timing mechanisms. They have to contain the cameras. They have to contain the underwater cameras that are both for understanding the mechanics of swimming, but also for the CBC. And they have to have, tracks have to be built into the system. And the facilities themselves have to be able to accommodate the study of the athletes at a high performance level when you don't have events going on. So this is just specifically for studying a hurdler moving through that facility, that earlier image of the woman with the dots on her face. These are high-speed cameras that measure every second of the movement, but actually every 100th of a second of the movement. So what that means is we have to kind of design the facilities to contain these things a very specific way. Originally in swimming, used to fire a gun, and everybody dive in the pool and swim across. Well, now you have to make sure that at every single block you have identical speakers, because sound travels about one side of the pool to the other in about 1/10 of a second. And as we know, often the winning in these things is 1/100th of a second, so that's an extraordinary debilitating thing if you're on the wrong side of the pool. So everything has to be tailored so it kind of has fairness, so we have to create these things. So that's the first thing, is designing for high-performance sport. The second aspect is, how do you pay for these things? How are they actually built? And this is where we get into a bit of politics, which I wasn't going to wander into today. But in this province, we have Infrastructure Ontario, and we have chosen to have an alternate financing and procurement model that's applied to all of these venues. So what's interesting about that is it has been a tremendous success for the Ontario government to have these private-public partnerships. And originally, how we used to build infrastructure in this province was with public money. But now with this format, we are now moving towards a new model which has created a provincial agency that procures from a private design build finance in the case of the Pan Am Games, but typically management as well. And it's created by, we have sponsors, the provincial government of Ontario. We create a compliance team, which is B&H, and then we produce a indicative design, which is then sent out to typically 3 consortia that are composed of very large teams that include financiers, but constructors and design teams. And then these meet periodically and present to sponsors and the agencies and us, the compliance side. And then finally, there's a technical and financial submission. These processes are sometimes 6 months long. And then at the end, a project company is selected, and a finance package is put out with them. And they have very strict rules about what can and cannot be asked for in terms of extras, what they have to provide, and also the schedule. And for this particular process, of course, schedule is everything. We had to make sure that the stuff was done on time. I'm not going to talk about the construction and operations because we'll talk about the construction in a second, but the operations were not part of this process. So in our case, we were scheduled for delivery of Toronto 2015. We started June 2010 in the process, and we are just coming to the end date in 2015. The concept was to have most of the venues ready for a year in advance so we can test out some of the facilities. So the schedule was very critical to that process. But also the budget was quite critical to the process. So all of these buildings, we designed them within a certain package, had them priced, and then so we knew that there was some comfort level for a kind of fully optimized sports venue, that it would fit within the budget model, and then it was put out on the street to the 3 consortia to bid on. So the velodrome is up and running already. It was one of the earliest ones to be completed. And weirdly enough, it was also one of the most complex ones to budget. It was under budgeted at the outset. It kind of complex bit of construction. It's quite unique, of course, because it's a very purpose-built project. But you know, it has happened. We pushed the envelope literally in some ways, and that the consortia proposed to bring it under budget to use a quite conventional sort of freezer panel, almost steel and foam insert for the cladding system, which has held up quite well, and it's actually developed quite a bit of efficiency in the process. And given that it's a very kind of relatively prosaic building type on the outside, it actually looks pretty good. And the interior of the track is apparently getting great accolades because all the attention went into the track itself. Hamilton Tiger Cats Football Stadium, York University Athletics are targeted to achieve substantial completion by April 2015. So I'm just going to go over this quickly because there was the Ontario auditor in the midst of all this issued a report that talked about some of the advantages of Infrastructure Ontario, that has a very strong record of delivering projects on schedule, which is of course very critical to this process. That the savings in terms of avoided risk are quite high, and that you know what you're going to get. But there is a possibility, and this is particularly in the DBFM, that there's a concept that it may actually cost more at the end of the day for the full delivery of these projects. And this is because there are 3 huge teams running these things, and the possibility that you're not quite getting the best financing that you can get, because of course the government can get money for 2% less than the rest of us. So, or not 2%, I'm exaggerating, but quite a bit less than the rest of us. So there's a kind of built into the process a slightly higher financing, which over the years the Auditor General said costs more. So there's these kind of checks and balances in this process. I'm just going to move past that. So we're going to talk about the actual venues that we're involved in. So these are the 6 sites out of the green sites. The idea, of course, of the Pan Am was to encompass the whole Golden Horseshoe. This is the Velodrome. I'm going to move past that because it's open. We already spoke of that, but I just maybe point out that it's actually a pretty good-looking building, given that it's all made out of Kingspan. The Hamilton Ticats has had their first game. So they've given a kind of nightmarish problem of getting the actual site, and then construction problems. It's kind of an extraordinary testament to the process that everybody managed to keep things on time, and it's open and running, and it will be there for the games, including the next season of the Ticats. The athletic stadium at York is just coming online now, and it is extending the legacy of high-performance sports at York University, which has kind of been a real benefit to York between the tennis and their kind of various programs. And already they're kind of assuming that certain records are going to be set in the facility because the track is so extraordinary in this part. I'm just going to go over the Etobicoke Olympium and how we try to save money by optimizing certain things. The Etobicoke Olympium, for those of us who have swum in our past, was the kind of center of high-performance sports in Toronto. It had one of the few 50-meter pools and diving towers in the city. It was a mess. I mean, the pool leaked like a sieve. The diving tower was scary. The mechanical system was awful, actually literally poisoning the people in there. And this is an interesting thing because swimming, when we talk about pools now, we talk about pools having fast water. And what's interesting about fast water is you sort of think, well, what does that even mean? I mean, how does water be slow or fast? But in fact, it's just how do you deal with the water to actually create a perfect environment for records and for high-speed swimming. And of course, what you do with that is you, first of all, have to make the swimmers comfortable. So the ideal is to make the water at a perfect temperature within 1 degree, and that's a kind of FINA requirement, which is the sports body. So from a mechanical side, how do you have to make sure that is the case. It's around 26 degrees. And that's because if the water is too cold, when you hit the water, it makes your muscles seize. But if it's too hot, you're not getting rid of the sweat because, of course, high-performance athletes, whether in the water or not, are sweating, so it's got to be a kind of ideal temperature. The next thing is to try and get rid of the waves. So the waves create energy. You have waves from the swimmer next to you and then waves from the rebound coming back. And so everything in the water has to be designed specifically to reduce the wave count. So that means the edge of the pools have to be designed just so the water, when the wave hits the edge, it flows over the side, gets absorbed, the energy gets absorbed out of that. Typically now we design 10-lane pools and we only race in 8. And then even the ropes are part of the system where the ropes themselves absorb wave energy from the swimmer in the next lane. So every aspect has to be designed to improve the performance, and that includes things like the depth. An ideal pool is the exact perfect depth because you also have rebound energy going down, but you have to be able to see the bottom of the pool. So if a swimmer can't see where they're going, they literally slow down because they start getting scared about hitting things and so on. The bulkheads have to be designed to not bend at all. They have to be fully rigid, but also light enough to move, because when they bolt off the starting piece, then the whole thing bends when they're all moving at once. So of course, if it bends, then the person in the middle loses some time, which of course means they lose the race. There's all these elements that have to be built into the system. So if you're taking water out of the pool, it has to come back in some ways because the level has to be perfectly consistent. so that all the mechanical systems have to be designed to kind of bring that water back in on a continuous basis, so that it's always at a kind of even level, so that everybody has the same situation when they're racing. So of course, when you have something like the Olympium, which has been around for a gazillion years, what do you do with it? So trying to bring that up in a kind of effective way is very difficult. So we relined the pool with a Murtha system, which is a stainless steel, basically, tub that you kind of put in there. It allows you to not have to take apart all the concrete and all the kind of issues with that. And it gives you a kind of perfect environment now to race in. We replaced all the bulkheads with a new set of stiff bulkheads for training. And then I created a new entrance, so it's a little more up-to-date and commodious. And then one of the things we did that was kind of interesting is the existing tower. We had a debate about how do we get this tower up to date, and then we thought, why tear the whole thing down? It's all there, it's kind of embodied structure, and part of the games also was to keep a kind of sustainable approach to everything we did. So we added steel platforms to the side, because of course all these platforms were too small, and now we have synchro diving, so you have to have a certain width in those platforms so that you can have the synchronized divers going off at the same time and not being too close to each other, and of course creating a dangerous environment. So all of this is all the existing system, and it's all being upgraded with these kind of new platforms to bring it into the modern era and bring it in economically. So this is just a kind of close-up view of that. Now, I'm going to talk about the Pan Am Aquatic Center, because it's kind of pushing this concept of the perfect pool a little bit further. And in this case, this is a massive facility, and Jeff is going to talk more extensively about certain aspects of it. I just want to talk quickly about some of the things that we did to sort of enshrine these ideas. So this is one of the winning, image of the winning design when we received the package. And I just want to take you through the design that we produced and how kind of close it actually is to the final product. But this is a huge facility. It's two 50-meter pools. One is the training pool, and one is the pool for the event, and then a 5-meter deep diving pool, both 10 lanes, and then a sports hall for fencing, volleyball, and other facilities or events. A full super high performance area here that's for training athletes and studying their movements. It's a thing between the CSIO, and I always forget what that stands for, Institute of Ontario, that's right, and U of T. And so all the kind of aspects that has to encompass. So we had to design a hall that somehow would go from having 6,000 seats during the event to how do you get rid of 2,800 seats, because that's really, you don't need all that many seats the rest of the time. Well, 2,800 seats is huge. It's much, much larger than this whole hall. So imagine making this hall disappear times 3. And that, of course, is in here. So we kind of worked on that idea, and that sort of, these are just the elevations, and the final product, which was based around a kind of central spine, which we'll get to in a second. I'm just going to skip over that because Jeff's going to talk about some of the concepts. This is the hall that we designed, the front entrance with its kind of amenity space and some notion about being able to see through the building to all the kind of aspects and have a cafe and make it quite lively. The actual hall to make sure it works. But this is where we get into how we develop the project. So we proposed that at this side of the building, and this is actually the winning scheme, we do this kind of big overhang, and then this is an area for drop-off. So any of you who have children who go to swimming events and so on know the kind of nightmare of pick-up and drop-off, of having your kids come out and almost getting run over by nervous fathers who are always late. And so we wanted to create a kind of idea here of a covered area that would work, but how that benefits the project is that then we have this overhang. This gives us an area to actually build out temporary seating in this zone, 2,800 seats, which you can actually start to see as the project develops. So we'll get to that in a second. We'll show sort of more of that. So now you see sort of the efficiency of the system, large spans, a kind of central space, and so on. But one of the things I want to point out is this site was a combination, and the end client is University of Toronto and the City of Toronto. And so this site was a jointly owned site, and it was a dump. So 10 acres of the site was fully remediated, and I mean, it's serious, nasty stuff. And so originally the idea was, well, it's all going to be excavated out and then filled in and then handed over to Project Co. And we looked at it, we said, but why fill it back in? In fact, why don't we excavate it out and then kind of bulk excavate it out to more or less the shape of the building that we had designed, and that's what we turned back over to the Project Co. So what that allows, of course, is a much faster build, but also typically you wouldn't do that. You kind of move the whole site up, but now the whole problem with Pan Am is how do you separate the public from the athletes, or the public from the politicians, or so to create that security zone. So what that allowed is the field of play is always below grade, and the public comes in above grade. So it allows a kind of perfect separation. That's a gift, because typically you wouldn't bulk excavate that much stuff out, but because the thing was a disaster and all the soil had to go, that we turned into an advantage, which is fairly rare to be able to do and to kind of optimize the process at that point. So this is just showing the structure and that kind of idea. There is the line you see of grade, and this is the full excavation, the structure. This is my 3D work, so just to go back to that. See, I actually do that stuff. Anyhow, and so this is showing the site with the kind of, really most of this was already excavated when the process started. And now you can see this is where that drop off and the kind of V system in that scenario. And then this is the final piece. So this is it in games mode. These are the exits for the temporary seats from this zone. And then this whole area that is right now kind of tarmac will be full of concession stands and so on in this component. So the public will come in at this area. And then when it's done, this all gets taken out and it gets turned back into that space, and the seats go away, and the seats are rented. They go on to the next games, the next Olympic Games probably. So that's a kind of real win-win for us, the front entrance. The diving tower and the whole setup and the fantastic acoustic panels looks much better than our design in the interior, I have to say. And this is the training pool with its moving floor and the field house itself. So now I'm going to talk about a downer for a second. So this is the U of T field hockey venue. So this is where legacy and the games kind of come in full contact with each other. So the field hockey has become something where we sort of think of it as a benign thing, and it's kind of a beautiful pile of grass, and everybody goes out and lies there, and then when it's time to play field hockey, you just pick up a stick and run around. Well, of course, that's not what it is at all. The technical system is a full blob of concrete, typically, or very compacted fill, and then very, very technical AstroTurf on the top. It's got to be a credit card flat with just a slight camber to make sure the water doesn't pond on it. And that's what it has become. And so you can see there's drainage like all the way through the field itself. So this is the kind of mythical idea of the field, and with brown spots and people playing, frisbee on it and so on, and soccer. And when U of T signed up for this, I think that was what was in the minds, even though it was presented as plastic. Everybody didn't kind of see it that way, and often you can tell people something, but when they're looking at an image, they don't quite hear the words. And so, of course, there was a huge uproar when finally the penny dropped as to what was actually happening in the field once this started happening and the thing starts getting dug up. And so the conflict of high-performance sports, which often doesn't have much to do with the rest of us who like to play frisbee and aren't high-performance athletes, comes into kind of direct conflict about what its legacy is going to be. Now, of course, this is an extraordinary field that will be used for all kinds of soccer and so on and so forth in its kind of AstroTurf mode, but its kind of romantic idea has shifted pretty dramatically from what it was. So, this is the process of the construction, this field, which was always a kind of bit of a mud heap, but nonetheless, as I say, people have a romantic notion of it. This is the beginning of construction, which of course the students were shocked by. And, the AstroTurf goes down. It's not very romantic looking at all, the whole process. But you know, at the end, I think aside from these towers and the conflict with Hart House, and we'll talk about lighting in a second, but I just want you to kind of remember these massive things. You know, the end effect is pretty good. Now, lighting is a problem for all of these sports venues because we don't have normal lighting anymore. Like a FINA lighting would be, which is like sports body, would be around 200 lux. We've now, everything's high def. So now you have to have 1,000 to 1,500 lux to actually do sports casting. So Signa has to have that for her group. And of course, it creates real problems because when it's too low, you get glare in your eyes, so you have to get it up quite high. So suddenly you have these huge towers to get the right lighting. So we'll see that in a second and the kind of how you deal with that in our legacy mode. So this is the Pan Am, the Atos Markham Aquatic Center, which we built out. It's a very simple building, but it had to actually exist in a future high density area, which is Markham Live, which is connecting the kind of front entrance to what is going to be a kind of new downtown core in Markham. Very simple layout, but at the end of the day, it has to be turned over to the city for just standard events. But it was to be the water polo, and table tennis and badminton. And it's kind of creates all those kind of standard problems that we have is how do you engineer a building for those aspects? And one of the things about badminton, like if you didn't know, and table tennis, it can't just be windy in there. It's got to be dead quiet. So you have to redesign all the mechanical systems. So when the bird goes up, it just somehow, or the shuttlecock as they call it, some ways, it isn't affected at all by the mechanical system. So the mechanical systems have to be quite specific. The pool itself, again, has to be designed as all the kind of fast water concept, and you can see that aspect there on the sides where you have a kind of extraordinary technology that's buried where you can't see it, but it's, again, all about taking the waves off, bringing the water back in, and not affecting any of the flow in this, that even though it's being used for water polo, it will be a high-performance pool at the end of the day. But then, what I was saying about the lighting is to get that kind of high-intensity lighting, you have to lift the roof up like a huge, long way. So this roof would typically be down here. So this is something you can't get around. You absolutely have to have this because otherwise you develop the glare when you have the kind of high-intensity 1,000 to 1,500 lux lights. But it's something that in legacy mode, the city is always going to be paying for because they will always have to condition that full volume of air that you typically would have. So this is these kind of things that you can't balance out, but you try your best to kind of optimize, but at some point you can't. And that similar condition exists in the field area. So now this is just showing the kind of layout that we try and create. This is legacy mode, and oops, that didn't work. Interesting. Anyhow, I was going to show you it legacy mode versus the games mode, but well, you can see it here, but you see the kind of three, you end up with three areas for badminton, and that's it, but the thing has to be designed for a layout like this. So the lighting system has to accommodate both in some manner, and so the way we did it ultimately was to kind of design a lighting grid that was basically dismountable at the end, so that, you know, at the end of the games, we can just move the lights around fairly simply and have a kind of distributed lighting system in that condition. And then we just tried our best to, of course, it's a great site, and we have kind of problems, of course, on all these sites where generally we have lots of parking. We're trying to create some flat areas, but we got to kind of remediate part of the stream, so it became part of our stormwater management strategy, allowed us to kind of open up some green on the site, and kind of reduce its environmental impact. This was a factory here. This was all tarmac, so it's kind of nice to return some of that to landscape. This is a bad image, but just showing, I wanted to show this because it kind of shows the concept of a very simple system of laminated precast walls with a full 5 inches of insulation, which is continuous, so you get some very good benefit from that system, and a glue lam structural system in the roof. And this is just showing the construction process, where we have the kind of steel system, high-speed construction. studies of the glue lamb that were all kind of done in quite a bit of detail with the manufacturer. The glue lamb going in, it's one of the longer spans that have been done in Toronto. Very fast direction. And then the final piece. So this was actually quite a cheap building. 78 million for a high-performance sports building is pretty good given the process and so on. But we kind of, I think this is all precast and it's looking pretty handsome right now. And one of the things we did just to add a bit of fun in two of the main facades was to add these metal elements, which are kind of representative of the flags of the Pan Am participants, and to break down this kind of, as I was saying, this is a very tall building given its function. It would normally, it would be that whole upper band wouldn't be there, it would be dropped down, but that was a requirement for broadcast. And one of the things we wanted to do is bring in a fair amount of natural light, but also provide privacy. So this is the pool, so we have a frit panel system here. So the cars are driving by, you're getting nice natural light in there, but you have the kind of privacy that's required for swimming. The front entrance. And I just, again, this, you can see this extra wide deck, so this is where all the temporary facilities go. And then in legacy mode, this is where the kind of training areas that they have, or pools, will be kind of set up along this zone here. This area here is all the cardio facilities overlooking the pool, so there's kind of nice interconnection between these spaces. And then this is the kind of legacy mode, bleacher seating, which again, that sort of secondary level, which is all the community-based rooms and so on, which are used for the kind of broadcast zones and so on the second floor, become community rooms for ballroom dancing and so on, but also so that the separation between where the athletes are and the public can access those zones. And one of the things we also did was this is a LEED silver building. We tried to build that into all of our Pan Am projects, which again is quite difficult because the lighting densities are very high. These are very energy intensive buildings typically. But just to kind of look at sort of aspects of the thing, we use the district heating and cooling. We have a substantial photovoltaic array going in the roof. We use glue lamp trusses using FSC lumber. We are doing additional measurement and verification, which I think is very important for sustainable buildings, so that you can actually see if they're performing to the level they should, and then you can tune the building and have the appropriate feedback, and that kind of fish and wildlife component that we added in to the site plan. And that takes me to 34 minutes, which is a little over my time, and thank you.